Hello guys, today we're going to go over animations and enemy AIs, and I'm going to show you exactly what we're going to go over today. So that way you can see, is this something I want to learn about, yes or no? We are setting up two types of AIs, and you might not recognize the difference in this one, but by the end you'll be able to notice which one is the root motion and which one is the NavMesh driven agent. So we're going to go over this, and specifically waypoints, like a patrolling or wandering. And we're going to do it in two different ways. And then on Monday, I'm going to do the multiplayer version. So let's get started. I'm going to give you the resources that I had for both of these videos. Let me pull up. So the first one is Lamb Academy. If you look here, he has a bunch of tutorials, and he has a part 42 where he goes over root motion. If you're doing single player, root motion is really good. And that's what I did to get this root motion guy over here. I'm going to remove these generators, NPC generators, so there'll only be one guy. And we're going to look deep into this. So there's two parts. The animation setup, and the animation has to do a lot with how the speed moves, because this is what's going to drive the speed of the actual AI. And then the second thing we're going to go over is the code. Okay, so you can see there'll be a little bit of jittering when it gets close to it. Those are things that you can fidget and fix with code and adding different types of animations when the AI gets there. Okay, so let's go into the details. In the previous, if you haven't seen, I'll put a link eventually to the previous video where I go over how to import animations. So I assume you already have your animations. In here, we have this network or root motion. Root motion just means in here, you could see that the animator, that the root of the animator is being handled by the script. Okay. And this NavMesh agent, usually what happens is the NavMesh agent is the one that determines where you're going to go. It says, okay, I need to go here, I need to go over there. And that is the AI, the path traveling part of it. And so you have to connect the animation with the agent to make sure that both are in sync. And so root motion just says, okay, we are going to go at the speed that the animation gives us. So let's go into that, because this is what's going to drive the rest. And I have my own blend tree for walking and running. Okay, and if you're going to do what in the video, if you go through the video with Lamb Academy, you will set up this blend tree for velocity X and Y. And then you're going to go into idle in here. In here, you'll have a state where it says idle. I personally didn't have it. I just set it up in the animation, but you could do either way. And maybe that's also why mine stutters, is because it's trying to animate back and forth. But you can have this, and you can have it go from this to that when it's done. Okay, but you can follow that tutorial. What I did is I want to show you first this blend tree that they set up. He goes in detail about it, but these are like the values that you might consider changing based on if these values are good or not. Because this is where you finesse the animations on the speed. Okay, so we have in here, see how he's walking, and he's at full velocity right now too. If I change that to this to 3, it can go up higher. And so I got to make sure I do 3 at all. And the position Y, velocity Y, is what determines how fast I go, right? So then this is full velocity. So now I have a bigger range, but see how like it's kind of like, that's not very good. And that's like a 0.5. So it depends on how much you want to give each of these values. The other thing is that on update, these values go up and down all the time. And so it's kind of tough. So you'll have to manage that. Then we have the left and right. And because of that, we have walking right, walking left, and the idle. So if I hit play again, or here, play, I can also, if I go velocity, it'll go to the right, or it'll go to the left, as you notice. And that's the root motion, is that everything is controlled by this, and it goes into the right or the left. And so even though it loops, because it's looping in place, it will control the movement of the character. Okay, so that is the power of these blend trees. And I'm going to show you the walking and running, because this is what I've did where if you can blend it all in one blend tree. So what you do in here, you can add another blend tree. And so I have 3 other blend trees. And so this blend tree specifically is 0 to 1. This is just how fast you go, because the idle doesn't need any speed, so this doesn't matter. So when velocity is at 0, it will be, okay, so here you go. So at 0.1 or less, it will choose to go to this blend tree, okay, right here. And we can name this idle. And then this blend tree is called walking, and this blend tree is running, okay? So this separates the blend tree. So it does it in 1D, so that way you can control within that, so you don't have any crazy weird jittering. I like it because it's easier to visualize. So you have a blend tree, and it'll go between idle, walking, and running, and these are the values. So I put running at 10, so that way there's a bigger blend between walking and running, and then there's less here. But you can change it. You can change this to 5, and I'll show you what that does. So we have 0, obviously, and we have negative. So let's put it at 0. The other thing is that these, as you notice, the difference, I changed here velocity x in here, because that determines whether you go right or left, remember? So that's why these blend trees, and that blend, -1, 0, and 1, is the left, the running, and the right. So either way. Does that make sense? So we have those there, and now we can go and test those values. So I can go here, and I'm at 0, 0. And then if I go forward, I'll start walking, right? And that's what you saw some of the tripping. Maybe I'll do this, 0. So that way I can immediately start walking. And maybe I need this. That's why I set it at 1, so they can walk faster. Okay, so we're at 3, so we're almost running. So let's go back to walking. Walking is at 2. So if I'm at 1, I'm kind of walking. If I'm at 2, I'm walking full speed. And then if I go right, we'll be doing the walk right. But see how it's kind of limping? Because there's something wrong with the way it's doing it. So the walk animation needs help because it's trying to probably blend with the idle, and the idle is kind of like, oh. And so this is where we have to like fix these numbers, these threshold values to see. Because if I go all the way to, let me see, if I go all farther and I'm running, so when I get to running, the blend is actually way better, right? And there's still that limping because the animations, some of these animations are off. Let me see. And you have to keep tweaking these, right? So that's where because it loops the pose and it shouldn't. You just need to loop the time. Okay, so you have all this. Let's try it again. See how it loops? That's kind of weird that it's doing that. Yeah. It's doing some weird blending with the with these, and so we'll have to change it so that way these animations are better connected, like with the speed. So let's go back to 1 and 5 maybe, and then do this 0.1, and let's see what happens then. We have 0, we have walking, we have running, and then see how these values are way better. There's still some kind of like jumping in there that you could see as you change these, but this is just a test, right? This is all root motion. And so a lot of the fixes happen here on the blend and on the import. So you have to tweak the animations to keep improving that blend if you like it or not. I have to probably re-import some of these to fix some of the issues that I see on it so that they blend nice and smooth so you're not getting that jittery. And I have to figure out what values are better. Also, what you can do is change it so that you're not blending everything together. You're just blending walking and running and doing different things. But anyway, so those are the fixes. The reason why I haven't delved deep into this is because the whole point of this video is the end goal is multiplayer game, a multiplayer enemy AI, okay? And root motion, I'm gonna show you the scripts now. We're gonna go in and I'm gonna show you why it's hard to do the multiplayer version. And here we have the base movement. And with root motion and with the Llama Academy video, it was all in one script, which you can do. But again, the whole point of this video is to show you not just what's possible to do in the moment with one enemy that just follows, but actually going through and finishing the AI for a production-ready enemy AI. So we're gonna try to implement a lot more than just one script. And so because of that, I'll show you the difference if you stick to the end of the video. And right now, root motion, one script, you can do it and you can test. This is a good starting point, but it's not the end of all. Okay, so we have the agent and the animator. We have apply root motion. This is crucial. This is why it's called root motion, because we are going to determine how fast everything goes. So you set it to true. You are going to update rotation by itself. The agent is going to be updating the rotation. That means that the nav mesh agent is the one updating the rotation. I'm not going to do the rotation. So as you saw in the Running Man, I had the velocity to the side and through. If I wanted to do that, then I would set that to false here. And that's why it's not using those rotations, because I haven't set it up for that way. And then if I want to do that, I would change it here. I would rotate based on the animator root rotation. See, so that is where it would change if I was setting diff. But right now, for the sake of simplicity, if you just don't want to deal with rotation, just set it to true and you don't have to deal with it. Now, agent position. You are going to update this. This is the speed, the position where the enemy is moving. You're not going to use the nav mesh agent, so you set it to false. If you are trying to, this is really good for when you are trying to interrupt animations to, or the nav mesh agent to make sure that you, like if you do jumps, so you're like, the nav mesh agent is going, you want to stop it, you stop updating position, you create the animation to jump on and attack, and then you put it back to true, to false, or then back to true. So you could do this to pause the nav mesh agent, play the animation, and then go back to the nav mesh agent. So this is a really good if you wanted to do a runtime, go back and forth. But for now, we're just turning it off because we're going to do it all ourselves. And the key is to use this on animator move. On animator move is the call that you use to apply the root motion. So we're going to, based on the animator's change, the animator is going to tell you which position you're going to go. So you have this call, root position, and then you're going to get the Y position from the nav mesh agent, the Y, because that way, if you need to go up and down, this will fix that. Okay, and most of these are explained in the video, so I'm going to go briefly because I'm assuming if you want to learn this, that you'll go to Llama Academy. The main thing is just showing you what's possible and why, and show you the difference, because we're going to go over a different tutorial after this, and I'll show you the difference. Handle movement. So in the handle movement, we just determine like, okay, like can we go to the next path? Is this, we go to the current position. So this is the targets. It's just a list of targets, and we set the destination, and then we wonder if it's waiting or it's pending. And then we check if we reached the position. It doesn't have to be like super tight. It depends on you if you reached, because that's what makes the jitter. So if you want to do it sooner, this will change if the velocity is less than 0.1, you could say. And if it reached and it's not waiting, it'll go to the next target. Okay, so these are, and then the next target, wait and go to the next target. So it's going to set the float. So you're going to stop. So you're going to set these animator values to X and Y to 0. You're going to wait for the idle time. And then you're going to go to the next target and set the destination. And you saw in here that we have handle movement and then synchronize animator agent. Because the main thing is that what you're doing is you're having to control these two. And you're saying who tells who what. So the agent is the nav mesh agent in the scene that controls where you're going. It does the pathfinding for you. So if you wanted to use something different, you could in here instead. But the nav mesh agent is the one that drives, okay, this is where we need to go. This is how far we are from destination. And the animator is saying, oh, we're going to control the speed. And so the agent needs to know from us what that speed is. And that's what we're going to do, synchronize animator agent. And here, we are trying to figure out the velocity. Okay, again, velocity X and Y based on where we're moving, okay, and where we need to go. And we set everything here. We have the animator. This transform position is based on the animator's root position and then the agent's next position. So we're doing a traversal and then smoothing it out. But the main thing in here is this on animator movie. And this is the reason why we can't network these so well, because of the order operations of how this behaves. So this happening, you can see that we are setting the root position. The root position is based on the animator. So the animator is doing the walking and setting up the speed. And so then we say, okay, the position is this one. This is where we need to be. And then the animation keeps going. So we can't, just setting the transform to a network transform doesn't solve the issue with these, because these are happening at different times than the update. It gets more complicated. So for my sake, I chose to go the other route. And this one, so we're gonna do the nav mesh agent one now. But that's about all you need to know about root motion. It's a Llama Academy video. It's just one video, and you can learn all you need to know about root motion and then expand on that. This playlist called the Introduction to MPC Behaviors is basically a game AI mastery course. And it has, I believe, 30 videos. Yeah, 30 videos, all very well done. I haven't even finished all of them, but I've already watched 13 of them, and they're amazing. And I've also been able to implement the network version of them because of the way that it's structured. There's a lot of things that are hard on this. It takes a while to learn all of it, and I'm still going through it. In here, we have a nav mesh agent again, but this time, as you see, the root motion in here is not checked on. See how this will change it to root motion. Okay, so we're not doing that. Instead, the nav mesh agent is the one setting the speed in here. And when I set it to 2, I know that that's like a walking speed. And so if you're going to do nav mesh agent speed to determine the speed of everything, you need to be aware of the speed that, so it doesn't feel like it's sliding. Because if I set this to 5, it's not going to work. But you can use the script to change it so when your speed is 5, the animation goes into a running speed and sets it at the appropriate rate. So you still have to balance the numbers, it's just at a different location. Okay, so we have this humanoid agent, the same as everything, but instead of doing the animation, let's go look at the animation like we did before. We have this simple movement, and it's the same blend tree as before with the 1D. So we have the idle, and then we have this running, walking and running. You can see that he is in place, right? So this doesn't have the root motion, whereas the root motion just had, it actually physically moved the character. This one doesn't, okay? Because it's gonna be walking, it's gonna be driven by the NavMesh agent. So we're gonna set 2, this is the speed at 2. Remember, because it's gonna go to 2. So that speed that we have in this guy here is the speed that it's gonna run to. And then the acceleration is like 8, so it'll be pretty fast. If you wanted to ramp up, it could. You just have to figure out like the ratio to make sure it's correct. But that is the basis, right? We have the same thing. We have a speed, and it just goes. There's no right or left because the NavMesh agent will drive right or left. But you can change. Eventually, we can do velocity X and Y the same way we did before and update this the same way. So we can still do all the same things. It's just that you have to be careful so that he doesn't slide. Okay, so the animation is pretty straightforward. It's the same as before. The only difference is that when you export the animations, they're not running in place. They're actually moving because that movement, that distance that it's moving is what's calculating the speed. So let's move this guy. Now with this setup, this is setting up for something in the future that is a lot better for AI and for what we're going to go with, which is behavior trees and state machines and mixing those and being able to do a lot more with these components. So what we do is we have an NPC, and it will show you in the video. Again, I'm not going to go over all the details because if you want to learn deep, just go to those videos. I vouch for those. I'm learning, I'm using them. But what I'm trying to show you is how you can then apply it to multiplayer and also your game, like how to tweak it, because that's a lot of times the hard thing is trying to grab a video, understand it, and then understand it enough so that you can use it for your needs. So we have this NPC component. And all this is doing, because remember, we just have these two things that we're trying to connect. And so we have this NPC that has access to the agent, the NavMesh agent, and the animator. So you have these two components. And so that way, anyone that needs them can access them. Because if someone's chasing, they'll need to tell the agent this and the animator that. But anyways, and then we have this current speed. So we're saying, hey, give me the speed. And it returns the agent speed, the speed of this guy. Because again, this is the guy driving the whole thing. And so in this time, the roles are reversed. The agent is driving the speed of the animator. Does that make sense? So anytime we need, so we are always asking, hey, agent, what's our speed? What's our speed? And then we say, hey, animator, this is the speed that we're at. Okay, so instead of going in here and telling the animator to what's our speed, we have different components. So we have an NPC animator. And what does the NPC animator do? It just, NPC animator set float based on the NPC current speed. So it says, hey, what's the current speed? Okay, let's set it in the animator. So all it's doing is linking the speed and say, hey, get the speed. This is the speed for the animator. Synced. Now the speed is the same on both the agent and the animator. And this makes it a lot easier than you saw before with the code. And you'll see in a second why. And this is inheriting from NPC component, which is basically just, hey, get the NPC component in here. And just this is a method that you can use so that you can inherit anyone that needs an NPC can inherit from NPC component, and it's going to get the parent. It's going to traverse to make sure it gets the NPC. Okay, this NPC that has the reference. Okay, that's all it is. So the animator says, hey, I can access the NPC. This is what I need, and this is what I do. On update, I just set the speed and I connect the dots. Okay, so these classes are nice because they set up a base architecture for what in the tutorials they're going to do in the future. And this is the Wonder script is basically the script that picks the targets. And so then the speed is already connected, right? We already have that. And so all we have to worry about now is like, it's not changing the speed, but actually helping the player decide where to move, right? Because the agent doesn't know where to move yet. But the moment the agent moves, the animator is going to know how fast to move, if that makes sense. So we are set. So this logic is very, it can get confusing. All we're doing is changing between wandering and waiting. So we're either wandering or we're waiting. And so then it just waits. So on the update, we're waiting or we're wandering. And if we're wandering, we're doing one thing. And so if we're waiting, we're just waiting for the time. And when the time reaches 0, we change to wandering. And it's the same thing for When we're wondering, we wait, and then we wait, and we're in the waiting. Okay, so we just go back and forth between the two, and that's all it's doing. And when we change the state, we say this is one of the values that is important is agent is stopped. Okay, and it's gonna make the player stop, and then we're gonna do what we need to do, whether it's wait or wonder. And then when we wonder, we need a destination to wonder to. And so we have set random destination, and this is the area. The area has just a random point in the area. So if you, if you look in the area, you'll see that there's a radius and there's just a random point in the circle. Okay, so this is not very, you don't even need this. If you wanted to, you could just create a random point here and just get that. So you don't need to have an area. That's only if you want to, right? Like it's just showing you the different things that you could do. And then has arrived is giving you that distance. It's like, is the distance, the stopping distance, the same as the remaining distance? And in here, let me show you one thing that you always want to be aware. This stopping distance is very important, because if you have this at 0, it is really hard to get it to 0. When you are getting close to that distance, it gets really funky. And so sometimes you might just say, hey, I'm already there. Like, don't worry about the rest. Or maybe you're, in the case of enemies, you're close enough where you can attack. You don't need to be like right at that spot. So those are things to think about. That's when things get really dicey or jittery. But there's a way to get around it or improve it and polish it. But that's not part of this video. You can have both scripts in one class. Like you can have one class that has all this stuff. I just wanted to show you see, there's one stopping. He's in idle, and then he goes. See, that's the 2. And then it just chooses a random area. So there's this, if you look in the area, see this area has a blue circle. And so if I change this area to here, he'll go over here somewhere. See, and then you go. And so that's the gist of it, is that we could literally have the same script that it's just the order of operation, right? And yes, the root motion is the one that's kind of harder to do, but it gives you the ability to make sure that it's tight and that it's going to follow the animation. So you don't have to tweak the animation speed. It will move at the speed of the animation. So it's just nice. But because I'm going to show you after this episode, I'm not going to go into root motion at all, because after testing it, I found out that it was a lot harder, and like that complication level, it wasn't worth the returns that it gave me. So I prefer the returns of the NavMesh agent, so that I could expand on. And I'll show you on Monday. It is so cool to see, like, it's the exact same behavior, but just tweaking it a little bit, and you can get it to be multiplayer. And so I'm excited for like all the stuff that we're gonna do, and then we're just gonna network everything, and it's gonna be amazing. Is there a specific game that you are making or that you want to make that you have no idea about? Post it below, comment. And if someone comments about a game that they want to watch me do, I'll dissect it. I'll show you how I would approach it, and I'll make videos on it. If you like these videos, please like and subscribe. It helps me out a lot. If you need specific help for your game, I also have a community called Endgame Devs, where I help developers finish their games. So we'll see ya.